Welcome to another explainer. All right, let's jump right into this because today we are unpacking a massive and honestly kind of controversial claim. Right now, there are billions, literally billions of dollars pouring into AI coding assistants. I mean, the big tech giants are basically operating on this assumption that AI can just independently write, verify, and totally guarantee software. But the source material we're looking at today says no way. We are looking at a fundamental limitation in artificial intelligence. The claim is bold. Programming is inherently not provable, and because of that, AI fundamentally cannot leverage it in the way we all think it can. We're going to break down exactly why the chaotic, unpredictable nature of the physical world throws a huge wrench into AI's supposed digital perfection. So, the big question we're tackling today really shatters a pervasive myth in the tech world. There's this super common idea right now, right? That if you just hand a coding task to a large language model, it can write the code, test the code, and perfectly guarantee that it works without a single human lifting a finger. Sounds like an absolute programmer's utopia. Just prompt it, get flawless software. But here's the catch. Testing something in a pure, isolated digital vacuum, where everything is just neat math and perfect logic, is completely different from releasing that code out into the messy, highly physical reality of human interaction. The digital vacuum? Safe. The real world? Total chaos. Section 1. The limits of provable programming. To really get why this is an absolutely crucial issue for the future of software, we first got to look at the boundaries of what we actually call provable programming. Like, where does this neat little theory violently crash into reality? So, provable programming is basically the theoretical concept that a script's behavior can be perfectly validated and mathematically guaranteed by an AI. Sounds awesome in theory, right? You run an automated test, the test passes, boom, the code is proven. Case closed. But our source material explicitly argues that this is practically impossible for AI to actually achieve when it comes to the real world. Why? Well, think about it. If an AI writes code in a purely mathematical realm, how does it know what gravity, or a dropped network connection, or just an unpredictable physical human error actually feels like? It doesn't. The AI is essentially grading its own homework in a universe where the actual laws of physics just don't apply to it.
Section 2. The Ubuntu screen blanking script.
Okay, to prove this limitation, the source gives us this absolutely brilliant micro-level example. We're going to look at a super simple operating system script to see exactly where the AI's logic completely falls apart. Let's set the stage here. Say I have a trivial, incredibly basic script running on an Ubuntu machine. Its entire objective, its one and only job in the world, is simply to blank the screen. Just turn the monitor black. I mean, in the programming world, it really doesn't get much more basic than this. It's essentially a one-liner, the absolute bare minimum. You'd naturally think, oh, an advanced AI would have zero problem writing and proving this code works perfectly, right? Section 3. The SSH illusion. All right, now let's see what happens when an artificial intelligence actually attempts to test and validate this very simple script. It enters what we can call the SSH illusion. Here's the play-by-play. The AI runs the script on the Ubuntu box remotely. It does this via SSH, secure shell, meaning it's logging in over a network from somewhere far away. It executes the command to blank the screen. The system returns 0 digital errors, none. The command executed successfully in the terminal. So, the AI confidently turns around and declares to you that the script is correct and fully proven. It absolutely believes it succeeded, but it is operating in a total illusion. Why? Because the AI only sees ones and zeros. It gets a success code, sure, but it lacks the eyes to see the physical monitor sitting in a room somewhere. It has absolutely zero context for the physical hardware attached to that machine.
Section 4. Physical reality strikes back.
Now here is where we completely pull the rug out from under the AI. We're going to introduce the messy, tactile reality of physical human interaction to this exact same script. And honestly, this is the absolute aha moment of the whole explainer. Step 1. A human sits down at a real local TDY, meaning a physical keyboard and monitor directly connected to that Ubuntu machine. Step 2. The human types out the command to run the script and physically presses the Enter key. But pay close attention to step 3. The very act of a human finger pressing that physical plastic key triggers the operating system's hardware interrupt to wake the monitor up. Yeah, the physical key press literally relights the screen at the exact microsecond the script is trying to blank it. The result? Step 4, the script instantly fails its real-world objective. The screen just stays on. This just brilliantly illustrates the massive blind spot we're dealing with here. On one hand, you have the AI's SSH environment. It's isolated, completely remote, there is no physical monitor to accidentally wake up, So the script registers as a total digital success. But on the other hand, you have the human's environment. It's physical, it's interactive, and purely because of the tactile nature of hardware inputs, the exact same script is a complete and total failure. The AI proved the code mathematically, sure, but it completely failed to prove it practically. This single point of failure proves the whole concept of provable programming wrong the absolute second it touches the real world. Section 5. The multimodal testing universe. Zooming out from just this one single Ubuntu script, this physical failure isn't just some quirky hardware bug. It reveals a massive, overarching limitation in generative AI that impacts how we build all software. I really want you to consider this direct quote from the source material. Even a trivial script belongs to a divergent universe of testing cases. Think deeply about what that actually means. If a script designed simply to turn a screen black can fail just because a human finger pressed a piece of plastic, imagine the infinite variables involved in a complex web app. I mean, what happens when a user swipes a smartphone screen with a wet finger? Or what if a user is walking down the street and their Bluetooth connection drops for a fraction of a second while the app is parsing an input? The moment physical reality is introduced, the testing case is multiplying to absolute infinity. It becomes a completely divergent universe that pure isolated code logic simply cannot contain. So the ultimate takeaway here is this. Large language models, as incredibly advanced as they are right now, fundamentally cannot manage the real multimodal user interface experience. There's just no way around it. Our apps and our software exist in a highly physical world of inputs and outputs, I/O. You physically touch screens, you move a heavy physical mouse, hardware reacts to actual light and temperature. But the AI? It lives in a text-based remote vacuum. It simply cannot simulate the tactile, messy, completely chaotic unpredictability of a human being actually interacting with physical hardware in the real world. Which brings us to the end of today's explainer and leaves us with a pretty vital thought about our collective future. As our digital tools become more and more embedded in our most critical physical lives, think autonomous cars, smart homes, life-saving medical devices, we absolutely have to recognize the hard limits of what AI can actually test and prove. If we just hand over the keys to AI, relying entirely on provable programming in a digital vacuum, we are ignoring the unpredictable nature of the physical world. If an AI cannot even predict that a single physical keystroke will wake up a monitor and break a simple script, how can we possibly trust it to completely manage the complex, multimodal user interfaces of our future without intense human oversight? It's a deeply fascinating limitation and honestly a pretty stark reminder that the physical world still very much belongs to us. Thank you so much for joining me for this explainer, and keep questioning the limits of the technology around you.